Welcome back. In this video we will review the most commonly used AutoCAD modify commands. With our AutoCAD software freshly opened and the default blank Drawing 1 open, let's start by opening our previously saved My Drawing file. Recall from the last video, we can open this file by navigating to the AutoCAD Start menu tab, selecting the My Drawing preview icon if it exists in the Recent Documents section, or navigating to the file's saved location by selecting the Open Files folder icon. With our drawing file open, we want to ensure we are on the Home tab. To the right of the Draw Tools panel we explored in the previous video is the Modify Tools panel. This panel contains tools used to make alterations to existing drawing elements. Keep in mind that accessing any of these commands can be achieved by selecting icons in the ribbon and also through keyboard input in the command line. As reviewed in the last video, each command, regardless of how the command is entered, the command line will present a prompt guiding the user and requesting the user to perform a next action, often a set of squared brackets presenting command-specific options, and sometimes a set of carets within which is the current option the command will follow, unless another option is selected. In the upper left corner of the Modify panel is the Move command icon, also accessed by typing Move or simply M and enter in the command line. Once the command is entered, the user is presented with the prompt to select objects. One very important point to make here is that for many of the Modify commands, the user can select the objects to be worked with prior to accessing the command. Both methods are effective. Let's select this line segment we relocated in a previous video. The command history states "one found," confirming the selection of the chosen line. This history feedback is important and helpful to the user. Should the number of objects found be different than intended, the user has an opportunity to make any necessary additional selections or removal of objects from the selection set. Let's quickly explore this concept by selecting additional adjacent lines with a forward blue pick box. With this additional selection, the command line history states 2 found, 3 total. We only want the one line. By holding the Shift key and selecting the undesired objects, we remove these objects from the selection set. The command line history states the number of objects removed and the total number remaining in the selection set. The command prompt to select objects will stay active until the user presses the Enter key or by right-clicking on your mouse. The command line returns to the common prompt to specify the base point. The base point can be a point on the object, a snap point on the object, or any relative point in model space, depending on the intention of the user. What are we moving, and where are we moving it to? In this instance, we want to reconnect our line to the adjacent line segment's endpoint to endpoint. By hovering our cursor over the selected line near the end of the line, the endpoint snap is recognized by the software. As mentioned in the previous videos, develop a comfort level in trusting the software to connect with the snap point being detected and resist the need to touch the detected snap point. Left-click to select the chosen base point. Move your cursor with your object attached to your cursor by the selected base point close to the line you are wanting to relocate this line to. Again, hover your cursor close to the desired endpoint, and when the endpoint snap, the green box is revealed, left click on your mouse to complete the move command. Remember the two important points just made. We can deselect objects by holding down the Shift key and selecting on the undesired objects, and to trust the software's detection and recognition of snap points to accurately place objects. Let's explore moving an object that shares different snap point types, all located at the same common coordinate point. For this example, I want to move this inscribed hexagon to another location. And note that the endpoints of this inscribed hexagon shares the midpoint of the flats of the circumscribed hexagon and additionally a quadrant snap point of the circle. What is the best way to approach moving this hexagon? The user needs to evaluate what is being moved and where is it being moved to. Enter the move command, and when prompted, select the inner hexagon. This may require zooming in with our scroll wheel to better see what we are picking on to avoid errantly selecting on the adjacent hatch, circle, or hexagon. Once the proper object is selected, hit the Enter key. Now to choose a base point. The safest snap point on this hexagon is any midpoint on the flats of this selected hexagon. Note, however, that this can be challenging if the hatch objects are set to be recognized. Again, zooming in super close is the best method to see and select this proper point. But I want to move this hexagon by the topmost point and to place this topmost point at the midpoint of the line segment we just moved. Moving our cursor near the circumscribed hexagon, we see the midpoint of the flat is detected. Moving our cursor near the circle, we see the quadrant point of the circle is detected at the same location. Moving our cursor near the flat of our inscribed hexagon, we see the endpoint is detected. Note we are saying near and not on the objects. With the endpoint detected, left click to complete the base point selection. The command line prompt requests the user to choose the second point or the point to move the object to. Zooming out with our scroll wheel is needed and panning with the scroll wheel is needed. We move our cursor near to the line we recently located. The software employs a 50% rule when detecting snap points. If the cursor now is more than half the distance closer to the end point than it is to the midpoint, the end point is detected. Once the cursor moves more than 50% or halfway towards closer to the midpoint is detected. And the user can left click, trusting the software to place the endpoint of the hexagon at the midpoint of the line segment. In this instance, we see that the hatch moved with its defining boundary. This is because the hatch was created as an associative element, meaning it is bound to the original defining boundary. By selecting the hatch and right-clicking, we see in the right-click menu a Hatch Edit command prompt. Accessing the Hatch Edit dialog can also be achieved through the command line. In the right-hand column, we see that the associative checkbox is checked. We will explore more of the options within this dialog in a later video. As is typical with all dialog boxes, we can close it with the X in the upper hand corner, clicking on the Cancel button if we wish to not save any changes that we have made, or by clicking OK. In the Home tab Modify panel, below the Move command, is the Copy Selection command. This functions differently than the typical copy and paste command using Control-C and Control-V keystrokes, or using the copy and paste commands found in the right-click clipboard flyout menu. When using the simple copy command, the items are copied to the machine's random access memory. When pasting the items, they are held to the cursor by a lower left-hand corner location and have no connection to the location of the cursor when the copy command is invoked. After selecting this rectangle and choosing Copy, note that the cursor is to the upper right of the display. When choosing Paste, note that this rectangle is attached to the cursor at the lower left-hand corner. When using these same steps to copy a circle, and choosing Paste, the circle is relative to the cursor as though there is a theoretical square about the circle. We can enter the Copy Selection command by clicking on the icon in the Modify panel, or by typing Copy or simply CO and Enter in the command line. As noted earlier, by selecting the object to be copied first, the Copy Selection command can also be entered via the right-click contextual menu. Let's select this rectangle and enter to complete the selection process. When prompted to choose a base point, select the bottom midpoint. The copied rectangle is connected to the cursor at the chosen base point location. The command line prompts the user to specify the second location. Where is this object to be pasted? Let's select the common midpoint of the circumscribed hexagon and the circle quadrant, again panning and zooming with the scroll wheel as needed. The command will stay in place and allow the user to continue pasting additional copies until either the Escape key or the Enter key is struck. Save your drawing, that fundamental habit. In the Modify panel, below the Copy Selection command is the Stretch command. We visited this briefly in an earlier video. The Stretch command automatically activates when moving or relocating whole objects, such as dragging lines and polylines by their midpoints, or circles and ellipses by their center points, or by intentionally selecting endpoints, midpoints, or quadrants to modify the selected geometry. When the Stretch command is entered either by selecting the icon or typing S and Enter in the command line, it is used to stretch objects by dragging multiple snap points from one location to another. To selectively stretch, in other words, elongate or shorten geometry, the use of the green back pick box or selection window is very effective. Recall that objects that are simply touched by this green pick window are recognized, but with the Stretch command, only the snap points touched by this green pick window become the active points on the selected geometry that will be moved or stretched. After entering the stretch command and at the prompt to select objects, let's use a green back select pick window about the right end of this rectangle and press Enter. When prompted to select the base point, the user can actively select a grip point on the geometry or any relative point out in model space. Once a base point is specified, the common prompt to select the second point in model space where the geometry is to be stretched to, moving our cursor, we see only the grip points that were included in the green pick window move. The remainder of the geometry remains in place. To the right of the move icon is the rotate command icon. This command allows a user to rotate objects clockwise or counterclockwise about a specific chosen point of rotation. We can enter the rotate command by clicking on the icon in the Modify panel, or by typing rotate or simply RO and enter in the command line. As noted earlier, by selecting the object to be rotated first, in this instance, let's choose this rectangle. The rotate command can also be entered via the right-click contextual menu. Since we have already selected our object prior to entering the command, the prompt to select the objects is bypassed, and the prompt to select the base point around which the object is to be rotated is presented. Let's select the geometric center snap point as the base point. At the prompt to specify the rotation angle, enter 30 and press Enter. By default, AutoCAD's positive rotation is in the counterclockwise direction. If the desired rotation angle was to have been in the clockwise direction, the user would type -30. Let's explore this clockwise rotation with this ellipse. Right-click menu, enter the rotate command. Let's specify the base point of rotation as this quadrant point and type -30 and enter. Save your drawing. Below the rotate command icon is the mirror icon command. We enter the mirror command by clicking on the icon in the Modify panel or by typing mirror or simply MI and enter in the command line. Unlike previously reviewed commands, the mirror command is not available in the right-click contextual menu in AutoCAD, but is available in other AutoCAD-based programs such as AutoCAD Architecture. If the intention is to mirror an object across the X or Y axis, having orthographic mode enabled is recommended. Let's mirror this ellipse directly to the right, a reflection across the Y axis. Enter the mirror command. Select the ellipse if it has not been previously selected. The next command line prompt asks the user to specify the first point of the mirror line. More often than not, there is a specific mirror plane the user wishes to mirror across to accurately reflect and place the object. In this instance, we will simply pick a point in model space just to the right of the ellipse. The command line next prompts the user to specify the second point of the mirror line, and using orthographic mode to our advantage, simply push the cursor up or down in the Y-axis direction. The user is immediately presented with a graphic view of where the mirrored object will be placed. Left-clicking will accept the placement of the object, but there is one last prompt to erase source objects as a question. And does the user want to erase or keep the original object? Yes or no? Note that the word no is within the carets, meaning that the original object will be kept unless the user selects yes in squared brackets or types Y or yes and presses the enter key to complete the command. We will accept no and press the enter key. We now have two ellipses. One is mirrored from the other. Let's explore how to mirror about a plane that is at an angle other than the X and Y axis, or the 0, 180 degree plane and the 90 degree, 270 degree plane. To do so incorporates the use of the @ symbol. Let's mirror this rectangle by 90 degrees in the clockwise direction, using the lower right-hand corner as the base point for the point of rotation and the first point of the mirror plane. Since a mirror plane splits the mirror distance or angle equally in half, our mirror plane must project at a 45-degree angle. 90 degrees divided by 2 equals 45 degrees. Enter the mirror command, select the rectangle, and press enter. Left-click on the lower right-hand corner of the rectangle, and for the first point of the mirror plane, and for the second point, type at 1, left caret 45. This statement is saying, from where I started, go 1 unit at an angle of 45 degrees, and press enter. Select no to retain the original rectangle, and press enter. The unit number value can be any positive value. 1 is just a basic and simple to type and understand value. The left caret is the keyboard equivalent for the word angle. Below the mirror command icon in the Modify panel is the Scale command. We enter the Scale command by clicking on the icon in the Modify panel, or by typing Scale or SC and enter in the command line. as noted earlier, by selecting the object to be scaled first, the Scale command is available in the right-click contextual menu. The Scale command helps the user to resize objects efficiently and accurately to be larger or smaller. Let's scale by 1/2 this ellipse that contains a non-associative hatch. When we select this ellipse and inspect its details in the Properties palette, we see that we could manually change the major and minor radii, but one of those dimensions is a very unfriendly fraction. Better to let the software resize this ellipse. Enter the Scale command, and at the prompt, select the ellipse and press Enter. For the base point, let's select the center point of the ellipse, zooming in as necessary to ensure we select the proper location. At the prompt, to specify the scale factor, type 0.5 or 1/2 as a fraction and press Enter to complete the command. Note that the equivalent of decimals and fractions are recognized. Which one the user chooses to input is a situational and personal choice. To the right of the rotate icon is the trim and extend commands in a contextual flyout. There are two modes that both commands can be set to. In the command line, typing the capital O as in the prompt in the squared brackets, we see that there is a quick mode and a standard mode. Each mode has advantages and disadvantages. The current mode is standard. For the moment, we will type Q and enter to change this setting to the quick mode. In the quick mode, we see that when hovering over a geometric segment, that a red X appears at the cursor and a preview of the extent that the geometric segment will be trimmed is shown. Left-clicking removes that segment. The command stays active until either the Escape key or Enter key are selected. When entering the Extend command, the experience is similar. Hovering over a geometric segment will preview the extent to where the geometric object will extend, and left-clicking again, the object will continue to extend until the Escape key or Enter keys are pressed. Below the Trim command icon in the Modify panel is the Fillet command. We enter the Fillet command by clicking on the icon in the Modify panel, or by typing Fillet, or simply F and Enter in the command line. Unlike previously reviewed commands, again, the Fillet command is not available in the right-click contextual menu in AutoCAD, but is in other AutoCAD-based programs such as AutoCAD Architecture. In simple terms, a fillet is a radiused edge or corner at the intersection of two linear geometric segments. An intersection of two linear geometric segments that come to a point or a sharp corner has a fillet radius of 0. Entering the Fillet command, the command line prompts the user to select the first object. We also see in a set of squared brackets a series of options. The most commonly used option is radius. Clicking on the word radius or typing R and enter in the command line leads to a prompt to specify the fillet radius. In the carets, the software is showing us a 0 distance radius will be used unless another input choice is made. Typing 0.5 or 1/2 as a fraction and hitting enter specifies a new radius of a fillet to be used, and the user is returned back to the first prompt to select the first object to be filleted. We will select the top leg of this rectangle as our first object. The command line prompts us to select the second object, and we will select the right leg of this rectangle. We now have a rounded or filleted corner whose radius is 1/2 inch. In the flyout portion, next to the fillet icon, reveals the chamfer tool. A chamfer is a linear, canted edge formed between two adjacent linear segments. We enter the chamfer command by selecting the chamfer icon in the Modify panel, or by typing chamfer or simply CHA in the command line. Upon entering the chamfer command, the user is prompted to select the first line. The first line segment to be shortened to create the chamfered edge. We also see a set of squared brackets with a series of options. The most commonly used options are distance and angle. Angle is a fairly straightforward concept, so we will explore modifying the chamfer leg distances. Left-click on distance within the squared brackets or type D and enter in the command line, and the prompt requests the user to specify the first chamfer distance. The distance, the first line segment, is to be shortened from a projected corner. We will type 1 and enter. The next prompt requests the user to specify the second chamfer distance. Inside the carets, the current setting is 1. Let us change this distance to 2 and hit enter. The user is returned to the initial prompt of select the first line. We will select the left vertical edge of this rectangle as the first line, and we will select the top edge of this rectangle as the second line. We now have applied a chamfered edge to this rectangle. Below the fillet chamfer icons in the Modify panel is the Array command. The Array command provides the ability to make copies of objects and arrange them in a controlled and defined pattern. A rectangular array distributes the copies of a base object in a series of columns or rows. The polar array evenly distributes the copies of a selected object about a circular path from a selected center point. The path array distributes the copies of a selected object along a predefined path. Specifically selecting the rectangular array, path array, or polar array icon in the Modify panel will enter that array creation method specifically. Note how each of these commands are named in the command line. Typing array or AR in the command line, the user will enter the array command and be prompted first to select the objects to be arrayed, and then prompted to select which type of array the user wishes to use, rectangular, path, or polar. Either command entry method by selecting the icon in the Modify panel or through the command line will bring the user to the same next step and prompt based on the array type selected. To explore these options, we will first escape from the current command, and we will create a new square using the rectangle tool at a random point in model space and type at 4, 4 in the command line. Enter the rectangular array command and select a new 4x4 square at the prompt and hit the Enter key. Note that the default rectangular array setting is 3 rows and 4 columns. There are several command options within the command line in squared brackets to be explored. For the moment, we will accept the default arrangement and press the Enter key to exit the command. Selecting one time on this array and navigating to the Properties palette, we see that there are a number of adjustments we could make to this array. The number of columns, the number of rows, the spacing in between, and other factors. With our cursor back in model space, we will hit the Escape key once or twice to deselect the array. Let's draw a random line from this array up and to the right some distance. Enter the Path Array command, and at the prompt, select this new rectangular array as the object and press Enter. At the prompt of Select Path Curve, select our new line and press Enter to exit the command. Again, within the squared brackets were several command options, and post-creation, there are many adjustments the user can make to this path array in the Properties palette. Let's now enter the Polar Array command. Select the Path Array as the object and press Enter. And at the next prompt, to select the center point of the array, let's select the geometric center of this rectangle. Note that the default settings for Polar Array is a polar array of 6 items that revolve 360 degrees about the chosen center point. Again, within the squared brackets were several command options, and post-creation, there are many adjustments that could be made to this polar array in the Properties palette. To the right of the Trim Extend icons in the Modify panel is the Erase command. We enter the Erase command by selecting the Erase icon in the Modify panel, or by typing Erase or simply E and Enter in the command line. Select the object the user wishes to erase and press Enter, and the object is erased. Note that selecting objects and pressing the Delete key will also effectively delete or erase objects. Save your drawing. Below the Erase icon in the Modify panel is the Explode icon. We enter the Explode command by selecting the Explode icon in the Modify panel, or type Explode or simply X and Enter in the command line. Exploding an object simply breaks the object down into more base components. A polyline, such as this rectangle, when exploded, when hitting the Enter key, breaks down into simple line objects. Note the squared midpoint re-entering the command, exploding an array simply breaks the array down into singular components. Exploding a hatch breaks the hatch into individual line segments and components. Below the explode icon in the Modify panel is the Offset command icon. We enter the Offset command by selecting the Offset icon in the Modify panel, or type Offset, or simply O and enter in the command line. The Offset command creates a parallel or concentric duplicate of geometric objects by a distance determined by the user. Entering the Offset command, the user is asked to specify the distance of the intended offset, and we will enter 2 and enter for this exercise. The next prompt asks the user to select the object to be offset. Beginning with this circle, once the circle is selected, the software previews the location the circle will be offset to. Moving the cursor towards the center of the circle previews the inward offset location. Moving the cursor outwards previews the location the circle would be offset to the outside of this existing circle. Left-clicking accepts the chosen offset location. The command remains active, allowing the user to continue offsetting objects. Selecting this ellipse does not allow or show a preview of an offset to the interior of the ellipse, since the smallest radius of this ellipse is less than the 2-inch offset being attempted. Left-clicking outside this ellipse reveals what appears to be a non-elliptical shape. Pressing Enter or the Escape key exits the command. Investigating this ellipse, by selecting on it, we see a number of grips around the perimeter of this ellipse. And in the Properties palette, we see that this ellipse, when it is offset, has been converted to a spline. A spline is a smooth curve that passes through or near a set of fit points. Re-entering the Offset command and exploring the options within the squared brackets, the Through option allows the user to select an object and offset it a free distance. Re-entering the Offset command and choosing the Erase option and selecting Yes, and we will reset our distance to 2, allows the user to erase the original object once the original object is offset. Next to the Modify label on the Modify panel is a flyout arrow. And by expanding this flyout menu, we see several additional Modify tools. We will focus on a related pair of commands, the Break tool and the Break at Point tool. The simplest way to think about the Break tool is to think of it as a pair of scissors used to cut or make a break in a geometric profile between 2 points and removing the geometry between the 2 chosen points. Entering the Break command by selecting the Break icon, or by typing Break or simply BR in the command line and pressing Enter, the first prompt requests the user to select the object to be broken. We will select the upper leg of this rectangle. The point at which the object is selected is the first cut or break point. The next command line prompt requests the user to select the second cut or break point. Once the second breakpoint is selected, the command automatically exits. The break at point command functions similarly to the break command, with the exception that only a single cut or breakpoint location is created. Entering the breakpoint command by selecting the break at point icon or by typing break at point as one word in the command line and pressing enter. The first prompt requests the user to select the object to be broken, with the second prompt requesting the user to specify the breakpoint location on the geometry. Once the second point is selected, the command automatically exits, and we see on our rectangle we have made a break in the rectangle, and we also have made a cut in one leg, separating two legs of this geometry. Directly above the break at point icon in the Modify Flyout pane is the Lengthen command. This command is very useful in modifying or adjusting a specific linear or curvilinear segment to a known and desired specific length. Entering the Lengthen command by selecting the Lengthen icon or by typing Lengthen or simply LEN in the command line and pressing enter. The first prompt asks the user to select an object to measure or select one of the options within the squared brackets. We will explore adjusting an existing line segment to be a new specific total length, and we see in the command line that the option total is current within the carets, and we will press enter to move on to the next prompt, which asks the user to specify the total length. We will use 20 units for this exercise and press enter. The user then is prompted to select the object to change. What is important to remember with this step is that the closest end of the chosen geometric segment is the end that will either lengthen or shorten accordingly. We will select the left end of this line, and we see that the left end of this line extended to the left while the opposite end remained in place. And save your drawing. This completes our review of the most often used modify commands in AutoCAD. In the next video, we will explore annotation objects and elements such as text, dimensions, and leaders, creating layers to manage your drawing content and drawing output, and at the end of this next video, we will save our own personal drawing file into the AutoCAD templates folder, and we will repath the new drawing saved path so that our personal drawing template file is opened each time AutoCAD opens or we select to open a new drawing file.